Right now, I want to solve the problem is the Jump Game 4. The Jump Game 4 is a solution to initially and give array, and we can operation go the other index. The index go rules is from this current index, we can plus one step and minus one step. And the third match the rules is if other index elements equals the current index element, and we can go reach the other index. And the result is reaching the minimum number of steps to reach last index of the array. So for the minimum number of steps, and we can use we can consider a BFS for the minimum number solutions issues. The BFS often BFS is the best choice. So we can go the for the BFS, we can define a QUE, and the Q. Then the Q is a Q go to the area ARI for the Q, and we choose the first Q framework is offer Q push the index initialize the index is 0 while Q is empty. Q empty, and we can return -1 3 and the int len equals Q their size. Then while so the first step is get the current Q Q pop, Q front, and Q pop. So for the -1 step and +1 step, we have to control it, and also we need to I need to the equals their size and size and visited. We need the visited vector. Visited and here visited to ensure the current index has been visited. If the visited and we don't care, we don't consider it. That's one. And master -1 and visited. We can set it visited and equals 0, not visited. Visited. And for this one, Q will add it to the next level. Add its next level, and the visited will be visited should be updated as visited as 1. So that is for +1 step and -1 step. this one. And then I will go the next step. So the next step should consider the same value for same title with the current index element. Same value. For the same value, I need to use a map. Use a map to record the same value index on all the region map set int and int map. So for every one, it's saved the list. Map will be saved in vector. VECTOR. It's include many index elements. Index has the same value. And for the auto X and map X will push back the index. Push back the index. For the index, we can go the index, save the index information. Equals 1 and size get the index information. And for this one, and we'll push the I. So get the same value. Once the same value, and I can go the next one for the same value. And if the same value, we can go for all the index same value. For the same value, I need to visit all the numbers. Same value get maps for int next and auto next to next and map ARI current value if we include the same value. If map contains this one, and I need to traverse the element or every element from this queue, from this map current, and then to check that every element is next. If next, also if the next has been visited, and I will to map erase ARI. So for the traverse is finished, and we need to erase the element from map because the second time we don't need to consider it. The second time all the elements has been visited, and we don't need. And the tricky, extremely example is like this one. For every element is the same value, and if the next element also the one, and we need to go go this for many times, and this is big O n square time complexity. If map found, map and erase, and then I need to have an interstep. It's one, and step plus if return step, the visited equals one, rated n minus one. So that will be compare the map. The map should be if map include this one, and we can handle the same value scenario, and if not contains elements, and we cannot do anything. So map found. I try to use a map found. I will try found the C++ an order map API, an order map API. How to find the API? How to find the element? How to find whether element exists in this map? It reads a second map as begin, map Q reference. Another map member function is begin Q as found. Map any found end. My map is end. Mapper found map end. Not end. Map element. I will try this one. Step. If input is only runtime additional assigned offsets, and the behavior syntax will be vector. Undefined behavior sanitizer visited. We can define so I will check the how to use the map.